Bismillah ar-Rahman ar-Rahim and Assalamu alaikum to you all. On behalf of WHE Education System, I welcome you all in my computer science class. Course code is 2210. Dear students, we have already completed chapter number 2 in previous week. In week 6 for class C1, format of this session will be carried out by taking review of chapter number 2 as a whole. Then we will solve examination question to practice the concept that we have learned in chapter number 2. In the end, an assignment will be given that you can download from DHA portal to solve. In week 6, we will take overview of the distinct feature of chapter number 2, which is communication and internet technology. After that, we will solve examination questions that are taken from the past papers. By the end of this lesson, students, you should be able to recall concepts, analyze question, devise solution, and observe the marking scheme for your question. In week 3, we talked about data transmission. Data transmission is the transmission of data between source to destination. Source is usually known as sender, while destination is usually known as receiver. Data is sent through wire or through wireless medium. Data in the form of binary is transmitted. It is first encoded, then the signals are processed, and then data is decoded to get the message at the receiving end. After that, we talked about 3 modes of communication: simplex, half-duplex, and full-duplex. These 3 modes of communication basically emphasize on the direction of the flow of data. So, in simplex data transmission, data is sent from sender to receiver in one direction only. Example is television broadcast. In half-duplex data transmission, data is transmitted from source to destination or from destination to source, but one at a time. Example of half-duplex is walkie-talkies or wireless communication. While in full-duplex data transmission, data is sent from sender to receiver or from receiver to sender simultaneously in both directions. Example of full-duplex data transmission is telephonic communication or video conferencing. After that, we discussed about 2 types of data transmission. One is serial data transmission and the other one is parallel data transmission. In serial communication or serial data transmission, data is sent in the form of byte, but one bit is sent at a time over a single wire. So data here sent bit by bit over a single wire from sender to receiver. While in parallel communication, data is sent in the form of byte, but all of its 8 bits are sent simultaneously from sender to receiver using 8 parallel lines that are usually known as wires or data paths. Serial data transmission is best used over the longer distance when there are less chances to intermingle the signal, while parallel communication is best used for smaller networks. Then we talked about asynchronous data transmission and synchronous data transmission. Both of these are the type of serial data communication. In asynchronous data transmission, bulk of data in the form of bytes are sent over a single line. Each byte is distinguished with the other by the use of control bit. At the start of the byte, which is the extreme right side, a control bit is added, which is known as the start bit. At the end of the byte, another control bit is added, which is known as the stop bit. This is how bytes are distinguished. In synchronous data transmission, there is no control bit used. However, data is sent in the bulk in the form of bytes over a single communication wire in the continuous stream of bits. There is a time session set between the sender and receiver for each byte. In the end, we talked about the universal serial bus or USB cable as the faster communication medium. Now let's discuss the topics of week 4. In week 4, we talked about error detection methods in detail. Error basically is a condition when the output information does not match with the input information. During transmission, digital signals suffer from noise. That means 0 bit is replaced with 1, or maybe 1 is changed to 0. So that can cause the error. The error can also be due to the hardware failure or software crash. There are various techniques to validate the data that we can apply on the data field. So we have validation technique. Validation basically is a process of checking if data satisfies certain criteria when you are inputting that data. We can apply the validation checks on the data field. We have different sort of checks that we can apply on a certain field. For example, range check, length check, character check, format check, limit check, presence check, consistency check, and check digit. Similarly, we have verification techniques. Verification basically is a way of preventing error when data is copied from one medium to another medium. For example, from your hard disk or from your CD to USB drive. So basically the verification is needed in that way when you're copying your data. So we have different sort of checks that we can apply. For example, double entry, visual check, and parity check. In the context of your syllabus, there are a few error detection methods that we discussed in detail, like check digit, parity check, checksum, automatic repeat request, and echo check. Now let's take a quick recap to see what were these. Check digit method. Before calculating the check digit, we need to know what the check digit method was. Check digit method is basically a method that possibly avoid transmission, transcription, and transposition error. A check digit is the final digit in the code of numbers. It is calculated from all the other digits in the code. Its purpose is to spot human error on data entry. So data entry is basically the transcription. So now let's calculate a check digit method with an example. For example, we are given an ISBN number and we are going to calculate the check digit for this ISBN number. In the example 1, you can see there is an ISBN number 0201538082 and the question mark is here, which indicates that we need to put check digit here. So we need to calculate that. So for the very first step is we need to put the digit position on each of the digit of the ISBN number. We'll start from the extreme right side and we'll increment the digit position by 1. So on the number we have put the digit position. Okay, let me tell you one thing. You can put the digit position from right to left or from left to right. When in the exam you're going to get some sort of question, always an example will be given. You need to comprehend that example, and then by following that the steps given in that example, you will be calculating the check digit. Anyway, now come at the step 2. Each digit is then multiplied by its digit position and the totals added together. So in this way we get the total, which is 98. In step 3, the total is then divided by 11 because in the question it is mentioned that you are using modulus 11 technique. So you will divide the total by 11 and the remainder, you will need to see the remainder. If there is any remainder, you will subtract that remainder from 11, and then this is how you're going to get the check digit. We got the answer after calculation 98. When we divide 98 with 11, we get 8 as answer in quotient, which is of no use right now. So we need to look at the remainder. Remainder is 10. Now we are going to subtract that 10 from 11 and we got 1 here. So this gives a check digit of 1. So the final ISBN number becomes 0201530821. So this is how the check digit is calculated, and the number ISBN number, when will be transmitted, the check digit will be sent alongside, and at the receiving end the check digit will be calculated or recalculated, and in the remainder, if somebody gets the answer 0, it means that the number is correct. So this was the method to calculate the check digit. Now let's see in another example how the computer recalculates the check digit. To check the correctness of a check digit, the computer recalculates it in the following way. Here we have another example. Again, we have taken an ISBN number. The number is 0131524447, and X is mentioned here instead of that check digit. So X is here. X in the question, it is mentioned that X to represent the number 10. So the very first step is the same. The position of each digit is considered. In the second step, each digit is then multiplied by its digit position and the totals added together. So here you need to see, you need to recall basically that X is equals to 10. So 10 will be multiplied with its digit position, which is 1. Then 7 will be multiplied with its digit position, that is 2. 4 will be multiplied with its digit position, that is 3, and so on. So in this way, we are going to get the total, which is 132. Step 3, the total is then divided by 11. If there is no remainder, then the check digit is correct. So we had a number 132, we divide it with 11, we got the remainder 0. This is fully divided. So we can conclude that the check digit is correct. So this is how we can check the validity of that check digit. Then we talked about the parity check method. Parity checking is one method used to check whether data has been changed or corrupted during transmission from one device or medium to another device or medium. In the parity check method, data is transmitted in the form of one byte alongside one parity bit that we add at the start of that byte. Now, the user, which is a sender, and the user, which is a receiver, need to agree upon the rule that whether data will be sent on the even parity rule or on the odd parity rule. In case of even parity, the number of ones need to be observed in a byte. If there are 2 number of ones, or 4 number of ones, or 6 number of ones, or 8 number of ones, then the parity bit will be set as 0. While in the odd parity, if there are 2 number of ones, 4 number of ones, 6 number of ones, or 8 number of ones, the parity bit will be set as 1. Similarly, the parity bits can be applied on the parity block. Table 2.2 is a thorough example of that parity block where the data is present in the form of various bytes, and at the start of each byte, parity bit is calculated. Internet. Simply, we can say that network of networks is known as Internet. When we are intent to connect with each other globally, we use Internet. Client-server architecture. In the context of network, when one machine acts as a server to provide the services and rest of the machine acts as the client to get the services, this is known as the client-server architecture. Web client is a user which puts the request to be executed, while web server is a machine that authenticates the request of web client and execute that request. Web browser is an application software that is used to open the web pages. Generally used web browsers are Internet Explorer, Mozilla Firefox, and Google Chrome. ISP. ISP stands for Internet Service Provider. This is a company that provides us with the services of Internet after charging fee. Protocol. Set of rules that defines how devices will communicate is known as protocol. HTTP. HTTP stands for Hypertext Transfer Protocol. This is a protocol that defines how messages are formatted and transmitted, and how server responds to various commands. HTML. HTML stands for Hypertext Markup Language. This is the language that is used to create web pages. IP addressing. An Internet protocol IP address is a unique 32-bit reference number that is allocated to devices on a computer network that uses the Internet protocol. MAC addressing. MAC is Media Access Control. MAC address is a unique 48-bit number assigned to a network interface card or NIC to identify it on a local area network. And lastly, cookies. A cookie is a small piece of data sent from a website and stored in a user's web browser while the user is browsing that particular website. Now let's solve few examination questions to practice the concept. 2. Here is the question number 5. I have taken from May-June 2018 question paper variant 1-2. Question statement is the three binary numbers in the registers X, Y, and Z have been transmitted from one computer to another computer. Now you can see register X and the binary value, register Y and register Z. Only one binary number has been transmitted correctly. This is identified through the use of a parity bit. You can see the parity bit is set at the end of this register. Identify which register contains the binary number that has been transmitted correctly. Explain the reason for your choice. Okay, so here we need to identify that out of these three registers, which one is correctly transmitting the binary number. So according to the even parity rule, we need to check this. Okay, so in register X there are three number of ones and the parity bit is set 0. Rather it needs to be 1. In register Y there are 5 number of ones and the parity bit is set as 1 to make it even. It means it is correct. In the third register there are 4 number of ones, so we do not need to make it even, so the parity bit needs to be 0 here. So we have understood that register X, there is something wrong with register X data and there is something wrong with register Z data, but register Y is correctly transmitting the binary value. So the binary number that has been transmitted correctly is in register Y. So Y is the answer. Now let's see the marking scheme to know the reason for this. Okay, you are going to get one mark for the correct register identified. So register Y is the right answer. Now you need to explain why register Y is the correct answer. So the total marks are 4 marks. 1 mark is already awarded. Now for the explanation, 3 marks are required. So at least 3 reasons need to be suggested. So here are a few reasons and you can write any 3 reasons from these. Count the number of ones and zeros bits in each register. 2 bytes registers have an odd number of ones or zeros. 2 have odd parity. So register X and Z both are having odd parity. Only 1 byte register has an even number of ones. So that is using the even parity. Okay, so the 2 with an odd number of bits or odd parity are incorrect. So register X and Z have an even parity. I have already explained while discussing while solving this that the register X and Z according to the even parity rule is not fulfilling the requirement. So this is how you are going to solve the question. Okay. Now let's take another example. Okay, this is question number 4 from paper May-June 2017. Question paper variant is 1-1. 5 statements about serial half-duplex data transmission are shown in the table below. Tick to show whether each statement is true or false. Okay, there are 5 statements given and the question contains 5 marks, so it is obvious that each statement consists 1 mark. First statement is data is transmitted in one direction only, 1 bit at a time. So for serial half duplex, we need to specify whether it is true or false. Data is transmitted in one direction. We know that in half duplex, data is transmitted in both direction, 1 bit at a time. So this the second part is true, but the first part is not true. So this statement is false. Okay, the second one is data is transmitted in both direction. In half duplex, data is transmitted in both directions. So this part is true. Multiple bits at a time. But the second part is not true because in serial, 1 bit at a time transmit. So this is also false. Third statement is data is transmitted in one direction only, multiple bits at a time. So this is also false. Fourth one, data is transmitted in both direction, but only one direction at a time. Data is transmitted 1 bit at a time. So this is the statement which fulfills serial half duplex condition. So this is going to be true. And the fifth one is data is transmitted in both directions, but only one direction at a time. So this fulfills half duplex criteria. Data is transmitted multiple bits at a time, which is false. So this is actually false. Now let's see the marking scheme. Yes, so we have seen this in the marking scheme. So to solve this question, you people need to be very clear about the serial transmission, parallel transmission, the concept about the half duplex, full duplex and simplex. So this is how you can easily solve this question. So one statement carry 1 mark. Let's solve another example. This is question number 5 from paper May-June 2017. Question paper variant is 1-1. Question statement A part is parity checks are often used to detect errors that may occur during data transmission. The received bytes in the table below were transmitted using odd parity. Tick to show whether each byte has been corrupted during transmission or not corrupted during transmission. So here we have a table. In the table we are given with the three bytes that are received. Now we need to see whether they are corrupted or they are not corrupted. Okay, you can for the first byte you can consider the parity bit at the extreme left bit or the extreme right bit, because nothing is specified here. Okay, so the odd parity has been applied here, so we need to see, for example, I am considering the extreme right bit as a parity bit. So the odd number of ones, I need to see the number of ones that are even. So this, according to the odd parity rule, this is not correct. So this byte is corrupted. Now in the next byte, there are four number of ones, and according to the odd parity, the parity bit needs to be 1. So it is correct. So this is not corrupted. So I'll put tick over here. And in the third byte, there are one number of 1. And according to the odd parity, this is corrupted. Yes, this is corrupted. So I will straight away mark tick here. So this is how I just need to mark tick here, and my concept of odd parity and even parity needs to be very, very clear to solve this question. Okay. In the B part, it says another method of error detection is automatic repeat request, ARQ. Explain how automatic repeat request is used in error detection. Okay, you need to see the marks of this. This is a descriptive question, so you need to write about the automatic repeat request method. For a quick recall, let me tell you, in automatic repeat request, we were having the request, we were having the acknowledgement, we were having the timeout things that are carried, that carries in the process, and the repeat is been the request is been repeated until it gets the acknowledgement. Now let's see the answer for both of these parts. Okay, the first byte, this is corrupted, the second byte is not corrupted, and the third byte is corrupted. If you identify it correctly, you are going to get 3 marks. Okay, for the B part, you need to write the theoretical concept, so you can write 4 points about the ARQ request. It uses acknowledgement and timeout, check performed on received data. Error is detected, for example, by parity check or a checksum or any other method. If error detected, request sent to resend that data, and so on. So this is something that you can simply extract from your book, and you need to write 4 valid points to get 4 marks. Now let's take another example. This is question number 4. I have taken from October-November 2017 paper. Question variant is 1-2. Statement is, a file server is used as a central data store for a network of computers. Rory sends data from his computer to a file server that is approximately 100 meters away. It is important that the data is transmitted accurately. Rory needs to be able to read data from and write data to the file server at the same time. A part is, use ticks to identify the most suitable data transmission method for this application. Okay, so we need to analyze the question. Rory sends data from his computer to file server that is approximately 100 meters away. 100 meters is a considerable distance, so it is a longer distance. Okay, so in the method of communication, serial goes best for the longer distance communication. So we will put tick in the serial. Okay. Next, it is important that the data is transmitted accurately. Rory needs to be able to read data from and write data to the file server at the same time. So when the both of the functions need to be performed, reading and writing, it means sending data and getting data at the same times. So for that, I think duplex method will be used. Yes, so you will put tick in the right box. Okay. Question, the second part asks, explain why your answer to part A is a more suitable data transmission. So let's see the marking scheme. Yes, we have marked, ticked at the appropriate boxes, and we got 2 marks. Okay, so why you have chosen serial instead of parallel? Because we know that for the longer distance, serial data transmission is considerably beneficial, and serial has lesser or lower interference. Serial is more reliable, accurate over the large distance, and signal intermingle doesn't get intermingle. So this is basically these are the reasons. And for the duplex transmission, we know that data can be sent and can be received in both directions simultaneously through the duplex. So this was the right answer. Again, let me tell you, your concept, your theoretical concept about these terms should be clear to solve this question. And this is how you can simply acquire full marks in such sort of question. We have another example. Okay, this is the B part. Identify and describe 2 methods of error checking that can be used to make sure that the data stored after transmission is accurate. Well, in this chapter, we have discussed about 3-4 methods. So you can write about, and this is of 6 marks. So it means for 1 marks, for 1 method, 3 marks will be awarded. So out of all those methods, you can write about any 2 methods in which you are proficient. So we have checksum method, parity check method, automatic repeat request method, ego check method. So you can simply write the description of these methods to get the marks. So this was a simple question. Now we have another question. This is question number 6 from question paper May-June 2016. Question paper variant is 1-2. Okay, this is very interesting and very simple question. This is of 6 marks question, and now you need to focus that how you're going to get 6 marks quite easily. A part, 3 descriptions of data transmission are given below. Take the appropriate box in each table to show the type of transmission and method of transmission. Okay, let me tell you, there are these 2 words, methods, types or modes of transmissions can be used interchangeably. So if for instance it has given in the question the type of transmission is simplex, half duplex, full duplex, do not get confused, because you people might have read the type of transmission is serial and parallel. So these are all types, methods, or the modes of communication. So okay, so description is given. So here we are given in the first box, we are given with the types of transmission, simplex, half duplex, full duplex, and in the second box we are given with serial and parallel transmission, which are the names of the transmission methods. Okay, and now we are given with a description. We need to focus on the description to put appropriate tick in these 2 boxes. Okay, data is transmitted several bits at a time down several wires in both directions simultaneously. Okay, data is transmitted several bits at a time down several wires. So this is actually about parallel transmission, and in both directions simultaneously. So this is the requirement of full duplex. So we will put tick in the full duplex and here in the parallel, against the parallel. Description 2, data is transmitted in one direction only. So we are clear about this. 1 bit at a time down a single wire. Okay, one direction only, that is the requirement of the simplex type of transmission, and 1 bit at a time, which is actually over a single wire, which is the requirement of the serial transmission. So this is simplex and serial. For the third description, data is transmitted 1 bit at a time down a single wire. 1 bit at a time down a single wire. This is the serial data transmission method. So you'll put tick over here. Okay, the data is transmitted in both direction but not at the same time. We know that this fulfills the half duplex criteria. So you will be marking tick here. So this is how you can easily get 6 marks. You need to be very alert, and you need to be very clear about the concepts. Okay. So this is how the full duplex, parallel, simplex, serial, half duplex, and serial. So this is how you got the 6 marks. Now let's see the B. In B part, it asks, give 2 reasons why serial transmission rather than parallel transmission is used to connect devices to a computer. Okay, you need to write 2 reasons for that. Like single wire means there is less chance of interference or data corruption. Single wire is also used to reduce the cost, more reliable over the larger distance. Bits will not get skewed up over a longer distance, so bits will still be synchronized after the transmission. So you can write any 2 reasons for that. So this is how you're going to get 2 marks. You do not need to write full-fledged stories about this. Rather, you need to write your answer in brief and exact concrete points. Okay, we have another example. This is a question number 9, taken from question paper May-June 2016. Question paper variant is 1-2. Statement is, in the following barcode, each binary number is made up of 7 bars. Each bar is black or gray. A black bar is interpreted as 1 and a gray bar is interpreted as 0. So here you can see in this diagram, this is a representation of a binary number. The black bars are representing 1 and the gray bars are representing zeros. Okay, A part is write a binary number that would be produced from this barcode. So this is very easy. So again, let me tell you that black bars means 1 and the gray bars means 0. So here you will be simply putting so this is 1, this is 1, this is 1. So you will be writing 1 1 1 here, then 2 zeros because they are 2 gray bars, then 1 1 in this box, and then the 0. So this is the binary representation of these barcode. For the second one, again you will be writing, this is the black bar, so you will be writing 1. Then there are 2 gray bars, so you will put 2 zeros. Then there are 3 black bars, so you will be writing 1 1 1. And then the last bar is the gray bar, so you will be writing 1 here. So this is very simple question. You need to comprehend the question, and it will be child's play. Okay, so this is how you are going to get 2 marks here. In the B part, it says this barcode system uses odd parity. Okay, write the parity bit for each of the binary numbers in part A. So let's see what was the binary numbers and how the parity bit will be set. Okay, so this is basically the representation. This is the binary representation for the barcodes. Okay, and now we need to see how many number of ones are there. There are 1 2 3 4 number of ones. These are the even number of ones, so the parity bit will be set as 1. Okay, in the next one, again this is there are even number of ones, so the parity bit will be set as 1. So this is how this question will be solved, and you are going to get 2 marks for this. So simply just by identifying the right parity bit, you are going to get 1 mark for each. This is another example. Okay, this is a bit theoretical question. This is question number 3 from paper October-November 2016. Question paper is 1-2. Okay, here part A asks explain what is meant by serial data transmission, and the second part of the same question is explain parallel data transmission. This is a 4-mark question, 2 marks for each. So you need to write about the serial data transmission, how data is being transmitted in the serial data transmission and in the parallel data transmission. Let's see the B part. A computer in a factory is connected to a printer. The printer is located in an office 1 kilometer away from the factory. Identify which data transmission method would be most suitable for this connection. And you need to give 2 reasons for your choice. Okay. I hope the question is quite understandable. So here in the B part, we got to know that uh, the printer is basically printer is located in an office 1 kilometer away from the factory. So 1 kilometer is considered somewhat a distance, a longer distance. So we'll prefer the serial data transmission, data transmission, or the connection should be the serial. And you need to write 2 reasons for your choice. So you will be writing about the description of the serial data transmission. Okay, now let's see the answer key. In the answer key, okay, so you will be writing at 2 concrete point about the serial data transmission and the parallel data transmission. Then again in the B part, whatsoever the method you have identified, serial goes best with this. So you will be writing serial and you will be explaining the reason, at least 2 reasons for that. And this is how the question. Now let's solve one more question. This is question number 7 from paper October-November 2015. Question paper is 1-2. This is variant 1-2. Okay. A part, check digits are used to ensure the accuracy of input data. A 7 extra digit on the right, so this is the right side, called the check digit. Okay, so you just need to see this digit position. So, and whatsoever the digit is, you will be putting the digit position. You're starting from left and moves toward the right, and the extreme side will be having the will be giving you the digit position. Okay, so this is the method. This is given in your question. So if you, for instance, forgets the method, just don't get worried, because for such sort of question, methods are already given in the question. Okay, the check digit is calculated as follows. Each digit in the number is multiplied by its digit position. So this is the question, and this is the number. So we will put this number under this digit position, and we will multiply each digit with its digit position. The 7 results are then added together. This total is divided by 11. The remainder gives the check digit. If the remainder is 10, so we can write check digit is X. Okay. So let's see the marking key to get the answer. This is very simple. Okay, so each digit is multiplied with its digit position, and the result is added up together. We got 105. We divided it with 11 because maybe modulus 11 technique has been used. 9 is the quotient. Remainder is 6. 6 is the check digit. The second part is an operator has just keyed in the following code number. So this is the code number. Has the operator correctly keyed in the code number? So we need to see the validity of the check digit, and we need to write the answer if it is not correct or if it is correct. Or okay, so we will simply apply the same method as applied in part 1. We will multiply each digit with its digit position, and we get the total. So here, for instance, we got the total 78. We'll divide it with 11. It gives 7 and remainder 1. It gives 7, remainder 1, and check digit should be 1. So this is how this question is solved. Okay, so let me tell you that the check digit here is incorrect. because it is not fulfilling the requirement, and the requirement is that if the remainder is 0, then your number is correct, otherwise not. So here we got a check digit which is 1. Rather, if we are having it 0, that means that this is the accurate value. So to just answer that whether the number is correctly keyed in or not, you are going to get 1 marks, and 2 marks you are going to get for the working and for the working for the calculation of that check digit. So this is how you're going to solve this question. B part. When data are transmitted from one device to another, a parity check is often carried out on each byte of data. The parity bit is often the leftmost bit in the byte. If a system uses even parity, give the parity bit for each of the following bytes. Okay, now 2 bytes are given, and at the extreme left we need to put the parity bit according to the even parity rule. So we will see the number of ones, so that needs to be even. If the number of ones are even, we'll simply put 0 over here. So we have 4 number of ones, so we'll even parity or the parity bit will be 0 here. And here the number of 1 is not even, so to make it even we'll put 1 here. So this is how you are going to get 2 marks by just identifying the parity bit. Okay. Second part, it asks, a parity check can often detect corruption of a byte. Describe a situation in which it cannot detect corruption of a byte. So there is one situation when the parity bit works, and that is if one bit is flipped during the transmission. But if 2 bits flipped during the transmission simultaneously, it usually fail to detect the error. So yes, in the marking scheme we can see 0 is parity bit and for the first byte, and 1 for the second byte. Okay, here we are given with the reason an even number of digits are changed or a transposition error has occurred. So this is how you can simply solve these questions by recalling your concept related to chapter number 2. Now you can download these questions and few other questions from the DHA portal to practice in the assignment. Thank you so much for listening carefully.